I didn't actually. Oh, it might be. Yeah, I'm kind of. Oh, it's good. I mean, that's what, you know. It's something that like trying to ball catch. Oh, just that's fine. That's fine. We'll continue like. Yeah. Oh, yeah. Yes, I don't really care. If you're doing like, if I you're like doing right, so I think, who knows, maybe it's that.
Okay, so we'll get started with today's lecture, everyone. Okay, so in today's class, we'll be covering storytelling, and this is an interesting topic. And I particularly like storytelling class because basically it helps you with your final project to think about if you want to do any kind of storytelling for your final project. It's this class has some really good pointers for that. So before we start, so there was a recommended or like a mandatory reading for today's class. It was a paper on narrative visualizations by Segal and Hare, and a lot of the course content for today's class is borrowed from that paper, and we will keep coming back to it. We'll have a brief discussion on the paper. Today's class also has an activity at the end, so in case you haven't submitted your 5 activities, you can use today's activity as one of those. So as we start, let's start by watching this short video. It's a bit long, but it's a really good watch. And after this, we'll discuss the visualization in the video. Let's see if the audio works.
How they thought wealth was distributed in the United States. This is what they said they thought it was.
Can everyone hear? Sorry, can everyone hear the audio? Yeah. Okay.
There's a chart I saw recently that I can't get out of my head. A Harvard business professor and economist asked more than 5,000 Americans how they thought wealth was distributed in the United States. This is what they said they thought it was. Dividing the country into 5 rough groups of the top, bottom, and middle 3 20% groups. They asked people how they thought the wealth in this country was divided. Then he asked them what they thought was the ideal distribution. And 92%, that's at least 9 out of 10 of them, said it should be more like this. In other words, more equitable than they think it is. Now that fact is telling, admittedly, the notion that most Americans know that the system is already skewed unfairly. But what's most interesting to me is the reality compared to our perception. The ideal is as far removed from our perception of reality as the actual distribution is from what we think exists in this country. So ignore the ideal for a moment. Here's what we think it is again. And here is the actual distribution, shockingly skewed. Not only do the bottom 20% and the next 20%, the bottom 40% of Americans barely have any of the wealth. I mean, it's hard to even see them on the chart, but the top 1% has more of the country's wealth than 9 out of 10 Americans believe the entire top 20% should have. Mind-blowing. But let's look at it another way, because I find this chart kind of difficult to wrap my head around. Instead, let's reduce the 311 million Americans to just a representative 100 people. Make it simple. Here they are, teachers, coaches, firefighters, construction workers, engineers, doctors, lawyers, some investment bankers, a CEO, maybe a celebrity. Now let's line them up according to their wealth. Poorest people on the left, wealthiest on the right, just a steady row of folks based on their net worth. We'll color code them like we did before based on which 20% quintile they fall into. Now let's reduce the total wealth of the United States, which was roughly $54 trillion in 2009, to this symbolic pile of cash. And let's distribute it among our 100 Americans. Well, here's socialism, all the wealth of the country distributed. We all know that won't work. We need to encourage people to work and work hard to achieve that good old American dream, keep our country moving forward. So here's that ideal we asked everyone about, something like this curve. This isn't too bad. We've got some incentive. Wealthiest folks are now about 10 to 20 times better off than the poorest Americans. But hey, even the poor folks aren't actually poor, since the poverty line has stayed almost entirely off the chart. We have a super healthy middle class, the smooth transition into wealth. And yes, Republicans and Democrats alike chose this curve. 9 out of 10 people, 92%, said this was a nice, ideal distribution of America's wealth. But let's move on. This is what people think America's wealth distribution actually looks like. Not as equitable, clearly, but for me, even this still looks pretty great. Yes, the poorest 20 to 30% are starting to suffer quite a lot compared to the ideal, and the middle class is certainly struggling more than they were, while the rich and wealthy are making roughly 100 times that of the poorest Americans and about 10 times that of the still healthy middle class. Sadly, this isn't even close to the reality. Here is the actual distribution of wealth in America. The poorest Americans don't even register. They're down to pocket change, and the middle class is barely distinguishable from the poor. In fact, even the rich between the top 10 and 20 percentile are worse off. Only the top 10% are better off. And how much better off? So much better off that the top 2 to 5% are actually off the chart at this scale. And the top 1%, this guy, well, his stack of money stretches 10 times higher than we can show. Here's his stack of cash, restacked, all by itself. This is the top 1% we've been hearing so much about. So much green in his pockets that I have to give him a whole new column of his own because he won't fit on my chart. 1% of America has 40% of all the nation's wealth. The bottom 80%, 8 out of every 10 people, or 80 out of these 100, only has 7% between them. And this has only gotten worse in the last 20 to 30 years. While the richest 1% take home almost a quarter of the national income today, in 1976, they took home only 9%, meaning their share of income has nearly tripled in the last 30 years. The top 1% own half the country's stocks, bonds, and mutual funds. The bottom 50% of Americans own only 0.5% of these investments, which means they aren't investing. They're just scraping by. I'm sure many of these wealthy people have worked very hard for their money. But do you really believe that the CEO is working 380 times harder than his average employee? Not his lowest paid employee, not the janitor, but the average earner in the company. The average worker needs to work more than a month to earn what the CEO makes in 1 hour. We certainly don't have to go all the way to socialism to find something that is fair for hardworking Americans. We don't even have to achieve what most of us consider might be ideal. All we need.
Okay, so we just saw this really cool storytelling video. Let's just go back to our keynote here. Yeah. Okay, so I want to discuss this video a bit, not the political aspects of it, but what did you like? How did you find this video? Was it meant to inform? Was it biased? Did it have a specific leaning? What did you like about it? Was it effective? So any thoughts, please chime in. Yep. Mhm. Mhm. Yeah, so like I would say this video basically the visualizations probably had some calculations behind it, but it's basically a video still, right? It's not interactive visualization. So yeah, you're right. It doesn't have any interactivity at all. But what do you think the purpose of such mode of communication is? Yes, please. Hmm. Yeah. Hmm. Yeah. Yeah, and of course, it was biased toward the American way because they explicitly mentioned Republicans and Democrats because it is about US, right? It is wealth gap in America. The goal of the visualization is that. So you are right, but you can also see the video is not really. They don't try to even be objective. They use the word the dreaded socialism with the tone of voice that implies some sarcasm. So yeah, so the goal of visualization is not always to be objective, but to communicate something. And your visualization can be biased, but as you mentioned, it was effective, right? Do you do you see using a video like this as part of your final projects? Some way to communicate? Yeah. Mhm. Yeah. Yeah. And so basically, in today's class, we will cover how to use visualizations to basically tell such stories, right? So when the purpose of your visualization is storytelling, you get slightly more control over the visualization. You are depending on the context, your visualization and your choices may or may not be biased, but the end result is meaningful storytelling. So let's started the video again. Yeah. So yeah, so the good stories do more than just provide facts and data. Usually, the goal of ideal visualization we put forth is to give us some hard facts, represent the data in an accurate way. But good stories go beyond that. They aim is to give some context, to educate, and to engage the audience in the process. They focus on the who, what, where, like the five W's and the how. And as all good stories, storytelling visualizations also have a beginning, a middle, and the end. If we go back to the previous video, you can see we started with this concept of ideal, what would an ideal distribution look like. Then in the middle, the author took some time to distribute American population and the cash in like different ways, and then explained how these different ways changed, and then at the end made their point about the top 1% compared to other 99. So a good storytelling needs to cover these three aspects, and a lot of the visualizations which try to do good storytelling are actually found in journalism. New York Times has one of the probably most prolific visualization teams, which actually generate really good data stories. And we'll see some of their examples. We also have an example from Bloomberg today we'll look at. But yeah, so good storytelling, even in visualization, needs to have a beginning, middle, and an end where you want to introduce the problem, then you kind of want to build up to what the point you're trying to make, and then finally bring it home with your resolution or your conclusion. So you should start thinking, if for your projects, especially if you want something like this, you should start thinking about what these three parts would be. So now we will again watch a brief video about Al Gore talking about global warming and climate change, and then we will see how he uses data visualization to kind of make his point, and then we'll see what using data visualization for storytelling gives us.
But compared to what's going on now, there's just no comparison. So if you look at 1,000 years worth of temperature and compare it to 1,000 years of CO2, you can see how closely they fit together. Now, 1,000 years of CO2 in the mountain glaciers, that's one thing, but in Antarctica, they can go back 650,000 years. This incidentally is the first time anybody outside of a small group of scientists has seen this image. This is the present day era, and that's the last ice age. Then it goes up, we're going back in time now, 650,000 years. That's the period of warming between the last two ice ages. That's the second and third ice age back, fourth, fifth, sixth, and seventh ice age back. Now, an important point. In all of this time, 650,000 years, the CO2 level has never gone above 300 parts per million. Now, as I said, they can also measure temperature. Here's what the temperature has been on our Earth. Now, one thing that kind of jumps out at you is, well, let me put it this way. If my classmate from the 6th grade that talked about Africa and South America were here, he would say, did they ever fit together? Most ridiculous thing I've ever heard. But they did, of course. And the relationship is actually very complicated, but there is one relationship that is far more powerful than all the others, and it is this. When there is more carbon dioxide, the temperature gets warmer because it traps more heat from the sun inside. In the parts of the United States that contain the modern cities of Cleveland, Detroit, New York, in the northern tier, this is the difference between a nice day and having a mile of ice over your head. Keep that in mind when you look at this fact. Carbon dioxide, having never gone above 300 parts per million, here is where CO2 is now. Way above where it's ever been as far back as this record will measure. Now, if you'll bear with me, I want to really emphasize this point. The crew here has tried to teach me how to use this contraption, so I don't feel myself. It's already right here. Look how far above the natural cycle this is, and we've done that. But ladies and gentlemen, in the next 50 years, really in less than 50 years, it's going to continue to go up. When some of these children who are here are my age, here's what it's going to be in less than 50 years. You've heard of off the charts. Within less than 50 years, it'll be here. There's not a single fact or date or number that's been used to make this up that's in any controversy. The so-called skeptics look at this and they say, so that seems perfectly okay.
Okay, so again, we looked at this. The goal of showing this presentation was to basically show how even politicians who are not really scientists can use these plots while communicating something in the form of a story. So Al Gore here basically showed correlation, but we could also show trends, we could show outliers. And for example, here, when Al Gore said he used this basically a lift to kind of go up and then point toward this is where the CO2 ppm measurements would be in next 50 years. He was basically using this. He was basically pointing at this extreme outlier to effectively make his point. And here, of course, he used a physical medium, but in your visualizations, you could also use some of these, as we saw in the first example, the first video, to show this 1%, the earnings of 1%, to show this outlier. They kind of animated the chart, broke it apart, and created an entirely new column. So using some of this emphasis measures allows us to effectively communicate different parts, outliers, trends, and correlations. So yeah, so storytelling with data goes beyond just facts and figures. It's also, the goal is also to engage people and then convey your points without making it dry. So now what are the components of a data story? So if you read the paper we had for today, we have this visualization, is this is fairly readable. But in the visualization we have, this is basically a visualization for different baseball players and how steroid use correlates with their home run record. So immediately looking at the first, the biggest thing in this chart is the title with the number of home runs and steroids or not, the pursuit is on. This, looking at this chart, your attention immediately goes to this first point, and now you know what this chart is about. As we move down, just below the big title, there is some context and a legend. So in the context, we basically have this, in context, we basically have different players the chart is showing, their home runs, or yeah, their home runs and the seasons they played in. It also has colors to kind of identify which line belongs to which player. And then we have the main story, the actual trend in home runs across season. We can see that they have used annotation to mark off a point where there is sudden increase in home runs uh, in the 14th season for I think, yeah, for Barry Bonds. So here, so in this chart, basically the biggest point, biggest thing in the chart is the title, which kind of attracts us and walks us through this story without there being any order specified. This is not an interactive visualization where we kind of are like walked through. It's just the flow of the way they have arranged the different parts of the data, the size and the colors kind of guide us through the story. And then of course we come to this context to, then we have this like small section of called context, where we have details on what the actual trend in home runs versus season should look like versus what it actually is for these three players we're focusing on. And of course, now that we have all of this main information, we now have basically information about other players to compare with these three players of interest. If you look down below, uh, we have like a couple of bar charts which show the same information, but in form of bar charts for many different players. And let's see, yeah. And if we look at Barry Bonds here, can anybody guess why they decided to also use bar charts in the bottom? Allow, since we are already using line charts on the top, why not repeat it down there? Why not just have multiple line charts instead of switching to a bar chart on the bottom? Yeah. Sorry, can you repeat the last part? Mhm. Yes, but also why? So with the line chart, well, you could argue that line chart also works here because it is consecutive seasons data. It's not real. We are not skipping seasons here, right? So a line chart would make sense. But what does a bar chart do differently than a line chart? And why do you, and just looking at the two charts, what immediately? Yeah. Exactly. Now, for example, if you look at the highlighted portion here, the 14th season is where the big jump in the home run record started. If we now look at the bar chart, you can see for the 14th season, we have this really tall bar, which is immediately visible compared to the line chart in the previous section. So that's why, so this story kind of guides us through. In the line chart where the jump is not immediately visible, they use annotation to point us to it. But then they also give us this bar chart, which allows us to see this for our own. And so this is an example. If you have read the paper, you will notice like the paper goes through a lot more of the nuances of how this plot was designed and what means of storytelling it uses. But yeah, so this is something. Oh, right, back. Yeah, so this is something you should keep in mind, that it's not always necessary to have some guided tutorial or video like format to walk us through a visualization. Usually a good selection of font size, plot sizes, and colors can help us walk through a visualization. So the paper describes types of data storage. So it basically has seven main types of data storage. First is a magazine style story, which if you look at magazines usually have this small visualization snippets on different pages, which walk us through the entire story. Second type is using an annotated chart. As example of annotated chart, we can refer back to our previous, the baseball example. That's an example of using an annotated chart. A partition poster. Again, the previous example also works well for a partition poster. A partition poster basically means you have multiple visualizations in one frame, and they all kind of tell a story. A flowchart, you must have used flowchart when basically describing a process. So they are another type of visualization. A comic strip is also an effective means of communication, and there was a recent paper on basically using comic strips to tell the story of a user evaluation in research. Slideshow is another great example of how you use visual storytelling. This is essentially what we do in this class. We use slideshows to communicate some story. And the the film, video, or animation is what our first example was, just using a non-interactive means which walks you through a story and kinds of acts as a guide towards a visualization. So now we can basically, these seven genres don't actually tell the same type of story. So we have the spectrum of different types of stories we can tell. First is the extreme side of the spectrum is the author driven storytelling, where the focus is on linearity. As someone mentioned, for the first video there was no interactivity, there was heavy messaging, and you had to see the story of wealth gap as the authors wanted to show it to you. Could forward the video, but you couldn't really control the order, stop somewhere and explore details. You had to rely on the author to tell you the story and the message they wanted. And the other extreme end of this is the reader driven story, where you basically get full control of the visualization or maybe multiple visualizations. There is no ordering, usually there is no messaging. And this is basically a visualization dashboard you might get, where you just receive a bunch of visualizations, you click on them to explore something. There is really no guidance. But a lot of most of the other visualizations kind of are in between these two layers. So there are three. So the paper mentions or describes three different ways to basically classify author or reader, or on basically creating storytelling visualizations, either towards the author or either towards the reader driven way. First is the martini glass structure, which basically, if you inverted it, looks like a martini glass, where you start with this author driven mode where the reader does not have any control of the visualization. They have to walk through uh, predefined keyframes or visualizations, and then the visualization actually opens up and full interactivity is given back. We'll look at an example of this visualization here. So this visualization shows US gun deaths in 2013. And the visualization basically starts with this line which goes on. The color represents basically when the death occurred, and the white part of the line represents expected lifespan if the person didn't die. And as we see, it speeds up, and at one point this visualization will stop and it gives us full control back. So we can see at this point it is still animating, the story is being told, and should stop anytime now. Yes. Okay, so it stopped in December. And now if we look at the chart, we can actually hover over each individual line, and it gives us the tooltip with the information about the person the line represents. It also has this filters on the bottom where we can, for example, say, just show me all the females who died, and then on the other side of the axis, compare it with the entire data set. We can add another filter of saying adult females, and then compare it to the other side. So this is a good example of having this martini glass storytelling. And this kind of storytelling basically gives the reader a basic walkthrough on what the visualization represents. It introduces different features slowly and then gives the full control back to the user to continue with the exploration. Another way to do storytelling is interactive slideshow, which is essentially what we like. This class can be thought of as an interactive slideshow where I'm actually walking through slides, but I occasionally stop and play some interactive mediums. And for example, you can think the example the paper mentions is a New York Times visualization where as you move, there is predefined set of visualizations you can move through in an order, but you can stop at any point and interact with the current visualization. So the interactive slideshows are a great way to quickly add some storytelling aspect. And the final storytelling mode is drill down story, which is let reader decide which path to follow, and like all the paths are annotated. So this kind of storytelling basically gives the reader different visualizations, the entire dashboard, whatever you want, and lets user do whatever they want, manipulate the views in whatever order, load any kind of data they want, and just explore it at their own pace. And this kind of storytelling can be interesting, but you have to really have good visualization design for it to be effective. I have an example here which does not work because my Firefox doesn't have Flash anymore. So I forgot to install Flash, but the example is made in Flash. It's a New York Times visualization. So like the slides will be published later, so you can take a look at the link later. So now let's talk about some strategies for storytelling. So the layout principle. So we'll talk about like 4 layout principles and then look at some examples on how we can use this for telling stories. So first is the descriptive titles, descriptive subtitles, annotations, and then saturation. So so especially saturation is something we have looked at before. Alex has covered it on how we can use saturation to kind of encode some information. But for storytelling, we will not use saturation to encode information, but to emphasize information. So let's start with these two plots. These two on the left, both the plots represent the same thing. They represent ice cream flavor preferences for my 2014 survey. On the right side, we immediately see that chocolate was the most popular flavor among the elementary school students because, well, it's in the title. They highlight their entire point. Then they also emphasize the actual bar. It draws our attention immediately. And if we look at the left side, the title says ice cream flavor preference based on 2014 survey, blah, blah, blah. On the right side, they put this information as a footnote in source, which is potentially where it belongs, right? We want to the visualization focus is on communicating that chocolate was the most popular flavor, and then you can look down to look at the source of this information. So this is one way to do effective storytelling without like resorting to animations or transitions immediately. Just using good titles, descriptive titles, which immediately show the point of your visualization, highlight the important part of your plot, and this and if you don't overdo this, it can look tasteful and it doesn't interfere with your encoding. For example, here we are using saturation to highlight that chocolate was the most popular flavor. It's on the top, right? If you also used color encoding and colored the bar with different colors, that would interfere with this emphasizing. So you should be careful when using one of the channels to emphasize something. Another example is this. This is a slope chart where on the left, where basically we have change in funding between change in funding before and after, change in gains before and after project funding. We can see on the left, it's if you look at the plot for a bit, you realize project A has the highest gain. But on the right side, the title immediately tells us the project A had the greatest gains because even though visualization is a great means of communicating, the title, the one sentence in the title is what we always end up reading first. And if your title has your biggest conclusion in there, it's the most effective way to communicate your strongest point. And of course, the other change in encodings is now instead of using the same color, we just highlight the project A, which is the main point we want to make, and gray out everything else. So another example of using a subtitle and annotation. On the left side, we have a basic line chart with number of studies funded each year. On the right side, we get some more context. We get a subtitle, which we can now read to find out more information about that. In 2013, they set aside new funding, and they also now annotate the point on the plot at 2013 where the new policy was introduced. So adding this simple things to our chart, let us tell an effective story without actually needing much effort in doing that. So descriptive title, subtitle, annotation, and saturation are like some of examples of things you can easily use to in your existing plots to just add the storytelling aspect. For Homer 6 also, we did something simple where we just highlighted two extremes. In our example, we highlighted two extremes, and hopefully for your implementation, you picked some other points to tell a story about. Now, other means of adding good storytelling, slightly more advanced, are interactivity, right? First, interactivity can start from navigation, where we tell a story as we navigate a visualization. So this can be using steppers, where you have a previous and a next button and you click on it to move through different plots. Then a scrolly telling is actually a popular way of telling a visualization story. If you look at Apple's website for any of their product, as you keep scrolling, the product moves around, they highlight different features of the product. It's basically like telling a story. I have this example from Bloomberg, which also does a scrolly telling example. So scrolly telling is basically scrolling plus storytelling. And here we can see that as I will move through the chart, I'll move through the page. I'm just scrolling up and down. The visualization updates, and it moves from 2D to 3D. It changes encodings, and if we keep moving down, we can see that it runs into this block of text you can read through, but then it again shows an entirely different plot, which also animates as we scroll. So this is a great way to basically, scrolling is a mechanism which people are already familiar with, to use this mechanism on a web page to basically have a nice story while giving users the control of how fast to move back and forth. In a video, you could do this with a video, but users don't have the same amount of control. So yeah, so this is a good example of scrolly telling, and I'll put up this link again. There are a lot of this example even on New York Times website for scrolly telling. You should take a look at those. So the second example is details on demand, where basically you start your visualization with an overview and maybe highlight some points of the overview, but don't show the details. Then when the users decide to click on something, that's when you kind of zoom in and then reveal the details. This is also a great method to handle large data, where if you have really large amount of data and if it doesn't fit on the screen reasonably, just aggregate it, compress it down, show a representative sample, and then as users click on them, reveal details of it. And the third is making it relevant to the reader. So making it relevant to reader. So what does this mean? You could potentially in your examples add some personalization. So you could ask the questions to user about what do they think, who they are, where do they live, and then use this to customize your visualization. A good example of this is this New York Times visualization again. Okay. Let me allow this, and let's open this in incognito because paywall. Okay, so now like I just gave New York Times access to my location, and it automatically picked Salt Lake City, Utah, and now it actually shows me the plot for Salt Lake City, Utah. Unfortunately, because of the paywall, I can't interact with it. But essentially, this drop down lets you type in any city in the US you want and look at the trends for the temperature that city for year 2015. The customization, or like the story, like the custom storytelling aspect that New York Times did here was to detect your location, customize the plot for your location. You can see the plot doesn't have to, you don't have to spend a lot of effort doing you don't have to spend a lot of effort customizing the visualization for different scenarios, right? Because the actual storytelling or the annotation part they're using are just parts of the data. They're annotating the highest points, the tide record high, the record high, and things like this, which you can do for any city programmatically. The only customization part is selecting a subset of the data. So this is again something you should consider when trying to select. This is again something you should consider when trying to create a good storytelling. How can I customize this to a reader in front? So yeah. So another example of this we'll walk through is again a New York Times example. Hopefully doesn't hit the paywall. Uh, is to ask for opinions or prior knowledge. So a good way to do this is to basically ask a user what do they think this means, and once they have their answer in, then show them the actual data so they can compare what their thought process or their understanding is different from reality. Let's look at this example here. Of course. Let me play. Nope. Let's try a different browser. Great. It won't let me play this, but okay. Uh, I have something in the slide. Yeah. So essentially, if you have a login, you can maybe explore this, but what this visualization shows is it shows this trend. It shows this trend for unemployment in Bush years. And then instead of showing the data for Obama years, what it does is it asks the users to draw on the screen what they think unemployment trend looks like, and then actually shows the unemployment trend data. And it does this for actually a lot of different attributes such as crime rate, uh, number of uh, undocumented immigrants deported, and it basically gives people a good mirror on how real data might compare to their own understanding, which may or may not be biased. So this is a great way to again juxtapose users understanding versus reality. So what are some design considerations when doing a good storytelling? Now, this visualization, it describes people dying on the road, but focusing on seasonal trends of this. It has three charts labeled 1, 2, 3, so you know you are supposed to read it from left to right. First is a line chart which shows fatalities in a month. The x-axis is month, y-axis fatalities. Second, we have a heat map where we can see that there are three different points in the heat map that immediately pop up for us. And on third, we have the actual reduction in fatalities. So this plot says there are fatalities that happen across the year. We can see that during the holiday season, New Year, 4th of July, Christmas, the fatalities particularly are up, maybe because people drink and drive. On third, we see that compared to what's this, like 20 years ago or 30 years ago, the fatalities actually have been coming down. So things are improving. So let's have a brief discussion on this plot. Looking at this plot, what do you think? Do you think it effectively communicates the data? Yeah. Mm-hmm. Yep. Yep. Good. Yeah. It is the visualization is cluttered. Yes. Yeah.
I would like to know how to do that. Days, bottom right, the hard cross,
Mhm.
why there was a big one, that would have been great.
Yeah. They don't have any reason. They just show that fatalities have dropped. No reason given. Yeah. Good point. Yes. Yeah, exactly. So, well, the lines, like the title says, the lines represent year. Exactly. So they doesn't tell us what year is each color mean, and frankly, the colors don't make sense, right? Because colors don't imply any order. So the encoding is not great. Good. And So how do you think what would you change in this visualization? We want to, so for this, we want to go through a redesign exercise for this visualization. So what would you change? Yeah. Okay. Yeah. Yes, sure. Well, actually, we didn't talk about the middle visualization that much. What do you think of using the heat map? Does it help you? The point they're trying to make is 3 holidays are particularly lethal. Is it obvious from the heat map to you? Hmm. Yeah, yeah, great point. Yeah, good. Yeah, and then you said it takes up too much space, so you maybe would have compressed it. Yeah, that's a good way to redesign. Hmm. So like use quarters instead of every single month. Hmm. Okay, yeah, that sounds reasonable. Yeah. Anything else? Okay, so we'll actually, so I have the redesigns. So the redesign for this was done by someone with the website Gravy Anecdote, and they basically did this as part of Tableau Design Month, where you basically pick a popular visualization and redesign it to be more cool or like more readable. So one thing you probably noticed here is if you look at the third column where we have a slope chart, it's not immediately clear that it's a slope chart, right? Because slope chart usually goes from one year to the other without the intermediate year, but the x-axis shows multiple years. And there is no way that the fatalities dropped linearly across these years. So it actually shows just the wrong information. It's not supposed to show the data for intermediate year, just to start and end, because we can see the actual trend of death right below in the fatalities in the chart below it, where it's not a straight line. So yeah, okay, let's start with redesign. So we'll use fewer colors. We will use averages to add more context. So instead of just showing individual data points, we'll also show like an average to show, so if some data points are higher or lower. We'll use better scales, as someone mentioned, like too many scales, and we will annotate and highlight some points. So here is the redesign. Yeah, okay, we don't have it zoomed in, but yeah, essentially what we did with the first line chart was, first, basically the axes now are improved. Instead of using the full names and turning them 90 degrees, we just use the shorter name because everyone can read it. It's still a standard way. Then we removed the color encoding. The color encoding represented nothing for the different years. Instead, all of the lines are now red. And then you added an extra line which shows average fatalities across all years. So this average kind of lets us take a look at, we can see that a lot more lines are below the average compared to above. And then we added annotations to the line chart, just marking the highest and lowest fatalities. So for example, in 2009, the for the year with lowest fatalities, August was the month with the highest point, and things like this. Then for the second heat map, we actually basically, instead of using the same color, we use a diverging color scale. So with the diverging color scale, we can basically highlight we can see that the holiday season like June, then 4th of July and December kind of have the really high fatality rates, while the others kind of fade in the background because they have similar rates. And then in the third, we explicitly made the slope chart just have two x-axis labels. And actually for the line chart, we, instead of showing the zero, we rescaled the y-axis to show the data. So I'm sure Alex showed this video once where truncating the y-axis or not showing the zero might not always be wrong. Sometimes it's okay to not show the zero. So not showing the zero lets us look at detail other let's just look at different trends and falls in the data. And then if you look at the reason, so you were asking, like, there is a small bump in the end. They added an annotation saying this is the time around where we had the financial crisis. So maybe potentially that's one of the reasons. But like actually the data maybe doesn't really include this, so I wouldn't like rely on that. But it just, maybe the annotation just works as marker for this big event happened this time, so maybe draw your conclusions. Sorry. Yeah, they also probably they actually increased the range to go from 1975 to yeah. Hmm. Hmm. Yeah. 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 It's probably, yeah, it probably is truncated. So during the redesign, they maybe added some data because the earlier chart was quite earlier chart I think just had data till like 2003 or something, 3 or 4, and then they added some data. But yeah, they probably increased some data. Yep. Okay. And then the next point is engage. Let's see. Yeah. Okay. The next point is engagement, like engaging the reader in our visualizations when we do storytelling. So, of course, when we don't know our audience, like when we design visualizations, usually, especially if you're doing it for a job or for communication, you should know your audience. You should design for a particular stakeholder. If you like in journalism, they kind of have a hard job where they have to now design visualizations for large public with different data literacy. But usually, if the reader is, let's say, your business managers, you know what sort of visualization literacy they have and what data to communicate. You can take into consideration if you are in a business organization, or let's say for your project, your goal is essentially other students and the professor and the TAs. So you should take into consideration who is our target audience. Or if you don't have a clear target audience, you should think of who my ideal target audience for this visualization would be, what they would like, what I would like them to get out of this, and then design your visualization around that. Always, before you like pick a chart type or have an encoding, think about what question would I like to answer, and then think of now what's the best way to do it. So now, based on target audience, we will do we have this really, I won't call it like a visualization, we have this like way of arranging different target audience from target audience in basically, should our visualization be a neutral or opinionated, versus should it have low information density or high information density. For example, a board meeting is a neutral, if you're designing visualizations for a board meeting, they probably should be neutral and low in information density, more on summary. But if it's a group meeting with, let's say, your software development team, maybe you still want to remain neutral, but go high on information density because it usually involves experts at that point. Then as we move on to expert panel discussion, let's say in a convention or conference center, it usually is very opinionated discussion. It's not really an objective discussion at that point, but it's still in high in information density because it's an expert panel. And then TED Talks or public media like journalism or even visualizations you see on TV, they are opinionated most of the times, but they are low in information density because they have to appeal to a large range of visual literacy. And then education falls somewhere in between. So this is again, like, this is not really a chart. I would say this is more like, you must have seen this. This is the kind of arrangements they like to do in business courses to arrange different concepts. So yeah. So for example, this bar chart, it just shows different shares of different, I think, operating systems or phone providers, phone manufacturers, percentage shares of them. Now, what would you think? Like, who's the target audience, and is this for? And what do you think about information density and the what do you say? How opinionated or neutral it is? Yeah. Mhm. Yeah, I would agree. Yeah. But what about this? Yeah. Yes.
I don't know if it's opinionated or not, but
Mhm. Yeah, anyone else? Anyone else have a different opinion? Yeah, it can be for a group meeting, and like with this much information, usually it is you would when you have this much information, and if you look at just the context of it, it is unopinionated. It's a neutral visualization, right? It doesn't really try to say we need more cells or we need less cells. Well, no one needs less cells, but yeah, it doesn't really try to put forward. It just shows data as it is. So yeah, it's probably high in information density, but not really opinionated. Now this, where there's smoke, there is cancer. This visualization basically has different rates of smoking versus rates of cancer, and it has all these different details, opinions. Yeah. Yep. Hmm. Yeah. And is it opinionated? Yeah, but if you just look at the title and things, you would say this is fairly neutral, right? It just shows that where there is smoke, there is cancer. It doesn't actually say don't smoke. It doesn't really give any opinion. It just gives the data as it is, right? So you could argue it's not really opinionated, because if you look at the titles of individual chart, none of them suggest do this, do that. It just show what it is. There is decline in smoking, there is decline of lung cancer, there is fewer deaths. It just shows that. Yep. Hmm. Hmm. Yeah. Yeah. Exactly. Yeah. I think it's more of just informative, like, hey, this is it. And maybe this on its own is not really opinionated, but it may be part of an article which maybe says don't smoke. So yeah, this. So Iraq's bloody toll. So this visualizes basically deaths in Iraq during the invasion across months or years. What about this? What do you think this is? Yeah. Mhm. Yeah. So would you say it's opinionated? I mean, yeah, it basically is showing the bar chart as blood spilling on your screen, right? So it's very opinionated, right? So yeah, this is it is kind of depends on how you look at it. Like, just if you look at the larger annotation, it's probably low in information density. Maybe if you go in details at individual plots, but it's highly opinionated and meant to tell. The title starts with Iraq's bloody toll. So it tries to give this opinion or give this side of the invasion. Now, there is another redesign of this, which, if you actually look at the data, even the first data, kind of, if you look across the axis, you see the deaths are declining. So, a redesign tries to put a spin on it, saying Iraq deaths on decline. So, again, this is the other side of the opinion. So, same data, same exact visualization, actually, but just change in color and kind of the context, the way they have situated this changes the story and the mood of the visualization. So yeah, this was done by Andy Codgreve, who like redesigned this to kind of show how you can go to extremes with just like adding this extra context. Yeah, and this is like how essentially you can put it. So the sales dashboard and the cancer infographic probably were high information density, neutral. He also put it as part of opinionated. So yeah, like I guess Alex agrees. And yeah, and the Iraq's bloody toll, uh, it depends. I would probably not put it in low information density, but it's definitely opinionated. Yep. So now we'll come to these exercises. Let me, before I start with the exercise, let me just quickly post a link in the announcements channel. Yep. So for this exercise, we basically have links to 3 different storytelling visualizations. First one is about, the title is very provocative, 1.5 million missing black men. It talks about incarceration rate for black people versus compared to the overall population in the area. Then second is about, is it the Earth's orbit, which explores change in Earth's orbit with change in temperature or like global warming. And the third is basically, over the decades have states of shift. This is again like a interactive visualization about switch of how states have uh, uh, changed from maybe blue to red or red to blue. So for all of these three, if you go to the link I shared, it opens a Google Doc. You can copy and you can submit this as an activity if you haven't done it. But what we want you to do is, for each of these visualizations, go to the link, play around with the interactive visualizations, explore their story, and then try to answer the questions of what genre the particular visualization belongs to. Is it author or reader driven? Can you make out one of the structures from the paper? The paper describes these 3 structures. So can you categorize the visualization in one of those? Does it have good introduction? Is the story opinionated or neutral? Basically, then your opinion on whether it uses the titles, legends, and highlight properly, interactivity, and overall if it's a well-designed visualization. Again, this is, you can submit this as one of your 5 activities. So you can spend rest of the time, like we have like what, 15 minutes or 10 minutes, I think, doing this. If you have any questions, I'll just stay around, and after that you can just leave. Yeah. I'll just open the Google Doc here in case. Yeah. And you can discuss the visualizations among yourselves, right? If you're sitting together. Yeah.